Trapezoidal approximation. Another method for approximating the area under a curve is the trapezoidal approximation method. Similar to the rectangular approximation method, the trapezoidal approximation method finds the area under a curve using the formula for a geometric shape, in this particular case a trapezoid. The height of the trapezoids will be the width of each subinterval, and the function values determine the base values of the trapezoids. You may recall that the area of a trapezoid is 1/2 times the height times the sum of the bases, and the sum of the bases are the parallel sides. For the interval width will be the height of the trapezoid, and the height of the two parallel sides will be f of whatever the values are. So if we have x value here, f of x1 will be the height of this side, and whatever this value is here we'll call x2. F of x2 will be the height of that side. Let's consider this example on how to use the trapezoidal approximation. So we're asked to approximate the area under the curve. In this case, the curve is y equals x squared on the closed interval 0 to 1 with 4 equal subintervals, and we're going to use the trapezoidal approximation. So first of all, let's calculate our subintervals. So we use our delta x b minus a divided by n, and using the values from above, we find out that our subintervals, each one is going to equal 1/4. We divide the function into 4 equal width trapezoids. So our first trapezoid will go from 0 to 2.5. It actually resembles that triangle. The second trapezoid will go from 0 to 2.5 to 0.5. Our next trapezoid goes from 0.5 to 0.75. And then finally, the fourth and final trapezoid has a width of 0.75 to 1. Let's set up the approximation using the area of a trapezoid. The height of each trapezoid is 1/4. Now remember, the height of the trapezoid is the same as the interval width along the x-axis. And also recall that the area of the trapezoid is 1/2 times the height times the sum of the two parallel sides. So plugging this into our summation formula, we're going to have 1/2. There's our height, 1/4. And then we're going to sum up the heights of the trapezoid. So we start here with f of 0. And then we go, the trapezoid ends here at f of 0.25. Now, the second trapezoid starts at 0.25 and goes to f of 0.5. So you'll notice there's a 2 here. The reason why there's a 2 is because this f of 0.25 is used twice. The end of the first trapezoid and the beginning of the second trapezoid. And that continues on for f of 0.5, f of 0.75. These are all used twice. The end of one and the beginning of the other. And then at the very end we have f of 1. So just to recap, note that the 2's account for the fact that the second side of a trapezoid is also the first side of the next trapezoid. Now let's simplify and solve. So how do we come up with this summation right here? Okay, we may recall that from earlier we had 1/2 times 1/4, which gave us our 1/8. Now evaluating our f of values, f of 0 and f of 1/4 and so on, we have, excuse me a second, we have f of 0 is equal to 0 squared. We're getting this from up here where it says y is equal to x squared. So f of 0 is 0. Next we do f of 1/4, and remember we're using our function up here, y is equal to x squared, so 1/4 squared is equal to 1/16. That's where this 1/16 comes from. Next we evaluate f of 1/2. Using our function, y is equal to x squared, we take 1/2 squared, which gives us 1/4, and that's why we have 1/4 right here. Continuing on, we're going to evaluate f of 3/4, which is 3/4 squared or 9/16. So we have 2 times 9/16. And then finally f of 1 is 1 squared. So right here at the end we have our 1. And when we work this whole thing out, we're going to find out we have a value of 11/30 seconds, which is 0.34375, or rounded to 0.344.